Notice what I've written down on the board. E is equal to negative 1.6 times 10 to the power of negative 19 coulombs. This is an interesting number. Robert Millikan, through an experiment called the oil drop experiment, found out that the exact amount of charge for one tiny electron is about 1.6 times 10 to the power of negative 19 coulombs. Negative, that is, of course. Now, in his first experiment, when he carried out the experiment, some of these calculations was wrong in air resistance, and so there were some mistakes that had to be corrected. But he wasn't really that way off with the number that he came up with, and we know that this is the exact amount of charge of an electron nowadays. But the most important thing that we found, and that he found, was basically that the charge of any electron is simply a multiple of this exact number. So we come up with a solution of calculating the charge of any electrons by using the equation Q is equal to N times E. This shows that electrons are quanta, and just like anything in quantum physics, they can just be a multiple of a bunch of other, like basically a specific constant number, and of course, the very tiny particles. So Q, which is the charge, electrical charge, which is simply the number of electrons, is denoted by the letter Q, and it is measured in the units coulomb, which is sometimes denoted with C. Now we have usually units that are way smaller than just coulombs, some stuff like microcoulombs, which is just micro means 10 to the power of negative 6, or we have things like nanocoulombs, so NC, which is another way of actually writing electrical charge, where nano stands for 10 to the power of negative 9. In this situation, E is clearly a constant number, and N is simply the number of electrons. Now, some of the questions you can be asked on this is technically finding the number of electrons, or maybe finding the charge in a specific amount of, a given number of electrons. So one question could be, for example, how many electrons are there in a 1 coulomb charge? Well, we know that E is a constant number, negative 1.6 times 10 to the power of negative 19 coulombs. We're looking for the how many, so it says we're looking for N basically. We know that the charge is 1 coulombs. So we originally said the equation was Q is equal to N times E. We have to rearrange this for N is equal to, if you divide both sides by E, the E's cancel out on the right side, and N, which is the number of electrons, is simply the electrical charge divided by the charge of one constant electron. Now, since we're looking for the number of electrons, we can consider the absolute value of the electron's charge, because the number of things cannot be negative, and so we should just use the positive number for the charge of the electron. So the answer would be 1 divided by 1.6 times 10 to the power of negative 19. So the number of electrons in a 1 coulomb charge, let me calculate that, is 6.25 times 10 to the power of 18. And that's a big number, which indicates there is a lot of electrons in a 1 coulomb charge. That's it. Thank you for watching.